Good morning, children. Today we will see about heating effect of electric current. So before understanding what is heating effect of electric current, we know that flow of charges causes current. Now, for the flow of current, we need a potential charges, or for the flow of charges, we need potential difference, that is V. So this potential difference, this is given by the battery or cell. That is what we learned in the introduction part of this chapter. Now, so the potential difference is created, the energy, the flow of electrons is started, and when there is a flow of electrons, it constitutes the current. But the current should be continuous for the, because the current should be continuous in the circuit, right? So for the current to be continuous in the circuit, we need an energy. Energy is needed. So this energy again is given by the battery or cell. How? Battery or cell. So inside the battery, we know the chemical energy is converted to electrical energy because of the chemical reaction, is converted to electrical energy. So using this energy, there is continuous flow of current in the circuit. Using this energy, there is continuous flow of current. Okay. So this is the understanding how current flows continuously in a circuit, which is given by the first few lines from this topic. You see, it says a battery or cell is a source of electrical energy. That is, here the chemical energy gets converted into electrical energy, followed by the chemical reaction within the cell generates the potential difference between two terminals and set the electrons in motion to flow the current through a resistor or system of resistors connected to the battery. So there is flow of electron happens because of the potential difference. Because of the potential difference, there is a electron flow. Electrons are in motion. But to maintain the current, the source has to keep expending its energy. So you see, this to maintain the current, the source has to have a energy. So where is this energy is coming from? The energy is coming from the cell. The energy is coming from the cell. That was the first point. So now, what is the question related to this few lines? How energy is supplied to the electrical circuit? E is electrical, so electrical circuit. Fine. So now we know that energy is being supplied to the electrical circuit. So what happens to the energy which is created? The energy which is created, so the same energy is used for two purposes. So the potential difference which is given by the cell is because of the energy also. So here what we are going to say is the energy given by the cell is spent in two ways. What is the first way? First way is this energy is used For maintaining the current, for maintaining the continuous flow of current in the circuit. That's what we see now. Second, what happens to the other way? What is the other way of spending this energy? Here the energy energy is spent in generating heat, So this is the two ways of spending the energy for maintaining the continuous flow. Some energy is used for maintaining the continuous flow of current, and some energy or rest of the energy is used in generating heat. So this maintaining the flow of current in the circuit is a must. So how this heat which is generated in the circuit is used, or how it is utilized, we are going to see now. And also the resistors, we add resistors also in the circuit. Not only a cell will generate the heat, resistors also generates heat, dissipates heat. So this is the next question. How the energy given by the cell is spent. How the energy given by the cell is spent. It is spent in two ways. One is for maintaining the continuous flow of current in the circuit. Other way is spent in generating the heat. Now, what happens to this heat? How this heat is utilized? So, the heat which is generated is utilized in two forms. What is one form? So, now the question is how the heat generated is utilized. So this heat, it is used in devices like fuse, and in the devices like the fan. How it is used in fuse and fan? In some devices, the heat is used for the rotation, work part. So energy is used for work done. What is work done? Like rotation of the blades, rotating the blades. The remaining energy or the heat, I am talking about heat. So some heat is used to do the work done, like rotating the blades. The remaining heat is used to increase the temperature. Is used to increase the temperature. So when I say work done, not only this rotating of the blade, it's also the bulb, glowing of the bulb. The bulb also glows, and the remaining energy or the heat, it is used to increase the temperature in case of fuse and fan or bulb. But in case of the electrical devices like the heater, the electric heater or the electric iron, the heat which is generated, it is only used, whatever the energy is there, the full energy, it is only used to generate heat. So here it is completely used only for generating the heat completely. There is no split of energy as for the work done and the increase the temperature. It is complete. The heat is completely used as heat inside the electric heater and iron. So when we use the complete energy for heating of the electrical devices, this effect is called as the heating effect of electric current. This is called as the heating effect of electric current. That is, we use the complete energy in the form of heat for the particular electrical device only, or we use the complete energy in generating the heat only. So when we use the complete energy into heat, That is called as the heating effect of electric current. So in our devices like bulb, fuse and fan, what we don't use the complete energy. Some energy we use it for work done, like glowing of the bulb or the rotating of the blade, and some energy is used, which is generated as heat, is used to raise the temperature. So this is what given in the textbook. The next few lines you see, a part of the energy, source energy, is maintaining the current may be consumed into useful work. So a part of the energy is consumed into useful work. Like what are the useful work? Rotating the blades of an electric fan. Rest of the energy may be expended in heat. It is generated as heat to raise the temperature of the gadget. For example, an electric fan becomes warm if used continuously for longer time. This is because, on the other hand, if the see why it becomes warm after a long time, so that heat which is given to the, so the energy given to the bulb, what happens, this bulb uses the energy to make the, it glows, uses the energy to glow, then the bulb gets heated up. So even after some time, when you use the bulb for a long time, when you touch it up, you will realize the heat. So that's what I said. In some devices, the energy is used to for work done like glowing the bulb. The another energy in the form of heat is used to raise the temperature. When the temperature raises, you can feel the hotness when you touch the bulb. So now what happens? This fuse, this rise in temperature should be maintained in the bulb. So these are all when we talk about the applications of the heating effect of electric current, we will talk about in detail about the fuse. But now you should understand one part is used for work, the other part is used as heat in raising the temperature. So now what happens in an electric fan, in what happens in electric circuit which is purely resistive, that is, we are talking about a circuit. Just look at this circuit which is given in figure 11.3. Here you could see that only resistors are used. Only resistors are used, no more the electrical bulb. So this is called as the steady. So in this type of circuit where you only connect the resistors, you see, that's what it says. The electric circuit which is purely resistive means only resistors are connected. So that is a configuration of resistors only connected to a battery. We find only the resistors. In those type of cases, we know that full energy is used in the form of heat. The source energy is continuously gets dissipated in the form of heat. So the energy is completely converted into heat. That heat is used in devices like electric heater and electric iron. This concept, this is known as heating effect of electric current. So that is the main question. So now, so this is how you have to answer this first para. So you have to say that energy is needed, that energy is used in different ways. One is in different fuse or the bulb, the other in the electrical devices. Electrical devices, the energy is completely used in generating the heat which is used in the electrical devices. There in that circuit, we do not have any electrical lamp. We only have the resistors connected. So now, consider, now we will, when we learn any concept in physics, usually it will have the formulas related to it. So now let us consider the charge work done in moving the charge Q across the potential difference of V. So we know work done is equal to, that is nothing but VQ, or I'll say VQ. So we know that this work done is nothing but energy. I can say, because energy is nothing but the ability of an object to do work is called as energy. So work done I can say as energy also. So energy is nothing but VQ. So Q is equal to IT. I can say VIT. So now, how this energy is related to power? So power is nothing but work done over time. The rate of work done over time is power. So work done onto time. So work done into time T is nothing but power. So power also I will say P is equal to VI. So now this energy, we know that it is given in the form of heat in the resistors. You see, the energy is dissipated in the resistors as heat. So now that is the reason I say instead of energy, I bring a new concept called heat. So the amount of heat produced in time t will be H is equal to V I T. So because we know that energy in the circuits like resistors and the electrical heaters and electrical iron, it's completely used only as heat. So that's the reason we have the amount of heat. We have a new formula, a new concept talking about heat, that is H is equal to VIT. So in an electrical circuit like electrical device like electrical iron or electrical heater, we know that the circuit has only resistors in it. So when there is a circuit with only resistors, circuit with only resistors will give me steady current, gives you steady current. So because of the steady current, how much is the heat produced is H is equal to VIT. So you have to write an answer till this for heating effect of electric current. So you can ask me how this heat is generated. Okay, fine. Energy is because of the cell where the chemical energy is converted into electrical energy. Where is this heat coming up from? So we know that the flow of electrons causes the charges is because of the flow of electrons. So when the electrons move, we know the kinetic energy is created. Because of kinetic energy, the electrons move. So while they move, some part of kinetic energy is lost. So that is given as the heat. So now then is, we will understand what is this concept. This concept of H is equal to VIT is, we can use the Ohm's law. So when I use the Ohm's law, so I know that heating effect is equal to VIT. I know because of Ohm's law V is equal to IR. So my heating effect formula will become IR into IT, that would be I square RT. So when I use the Ohm's law and derive a heating effect formula, this is known as Joule's law of heating. It was found by the scientist Joule. So what is next question? This is a question. Explain the Joule's law of heating. When you explain the Joule's law of heating, you should talk about the Ohm's law, application of Ohm's law in heating effect of current. Now, so what is the Joule's law? Depends upon I square T. So it depends directly proportional to the square of the current for a given resistance, directly proportional to the resistance of a given current, and directly proportional to the time for which the current flows through the resistor. So now here H is directly proportional to I square R and T. And this is a circuit. If they ask you to draw a steady current, you should draw a circuit with only with resistors. So this is a circuit for resistors. So now what is the unit for this heat H? The unit is joules. So the unit is joules. It's energy, work done, everything. This is joules. It also is termed in terms of joules. So now what happens if the current is doubled? Here if the I is, consider I is doubled. So what happens to the H? So here because I is doubled, I know it is going to be 4 times of heat. So I is equal to 2I the whole square. So H is equal to 4 times of I. So H is 4 times. 4 times is increased. 4 times of heat is generated. Then what happens if the R is doubled? What happens if R is doubled? Then H is equal to 2R. So double the heat. Double the heat will be produced. So double R is equal to double the heat is produced if R is doubled. Then suppose if R is halved. If you half the R, then heat is also only half the heat is produced. Half heat is produced because everything is directly proportional. So now if the time is doubled, so if T is equal to doubled, we know that the heat is also doubled. Heat is doubled. So this is understanding when we increase the quantities. So what happens if the components I, RT are increased or decreased? Directly it will affect the heat, which is directly proportional to the I square RT. So the next would be the explanation of application of heating effect of current.